Good morning, everyone. First of all, thank you to the ICANN community for providing me an opportunity to be here as a NextGen fellow. Today, I'm going to talk about my research, which is a study on unwanted DNS queries to b-root server. This is a joint work with my advisor, Professor Yelena Mirkovic. Next slide, please. What if I told you that more than 70% of all incoming queries to root servers are unwanted even today? I see some eyebrows raising, which is not surprising, and this actually drives the need for our research. Just to make sure everyone is familiar, DNS is the phone book of the internet, which is responsible for translating human-readable domain names to IPv4 and IPv6 addresses. This also helps humans to navigate the internet without having the need to memorize those numbers. Additionally, DNS is structured hierarchically for efficient management, in the sense that no one entity is controlling all parts of the internet or all parts of DNS. At the top of the DNS hierarchy is something known as root servers, which process billions of queries every day. These root servers are authoritative for all top-level domains like .com, .net, .org, and other 1,500 of them which exist today. There are 13 root servers in the world named A through M. However, there are more than 1,800 instances of these root servers replicated across the world, located at different physical locations, making use of Anycast technology. As with any research, the first thing we ponder about is what is the need for this research? How is it going to be productive? Will it make a change in the ecosystem? There have been research on queries that arrive at root servers from the past 30 years. However, we find that there has not been a comprehensive analysis of all the incoming queries. So we propose to do a comprehensive analysis with an intention to understand the root causes of such queries. We find that there have been faults in resolver softwares. There have been different kind of applications, more recently IoT devices. And last but not the least, the user in the loop who has also been misbehaving at these queries and then sending them to the root server. We intend to identify the sources that are responsible for all unwanted queries that come to the root server. For the approach, we look at all the incoming queries for a duration of 11 years. For this, we make use of data set from what is known as DNS-OARC. DNS-OARC is the organization which facilitates something called DITIL, which is Day in the Life of Internet Collection. It collects data from interesting resolvers, authoritative name servers, and root servers across the world for a period of 48 hours every year. This data is available on demand. Anyone can place a request where DNS-OARC get access to the data. b-root has been participating in this effort since 2013, and our research is based on data for 11 years, starting from 2013 until 2023. The data set itself contains, I think, 35 different parameters, but for our research, we pick these 4 parameters that we can see here to understand what kind of queries come in. First one is the timestamp, that is the time at which a query arrived. This time is measured in epoch time, which is seconds that have elapsed since 1970. The second parameter is the source IP address, which is the IP address of the source that sent the query. The third one is the name, which is the query itself. For example, www.isi.edu or google.com. And the last one is queue type. We have different queue types, but the most prominent ones, I think I've listed them there. The queue type A stands for IPv4 address, quad A stands for IPv6 address, the others are mail server and name server. Next slide, please. Using those 4 parameters, we look at queries and classify them. These are the unwanted queries that we see. Repetitive queries are queries to existing TLDs, which occur within a prescribed TTL, time to live window, by the operators of TLDs. We find that absence of caching mechanisms at the resolvers can be one potential reason for repetitive queries arriving at the root servers. The other thing can be that there are no resolvers at all, and there are independent devices which are trying to talk to root servers directly. We also observe that there has been a bias in caching mechanisms for different queue types, such as IPv4 and IPv6 addresses are cached for a longer period of time in comparison with mail servers and name servers and other types. For the queries to unallocated TLDs, these are the major chunk of unwanted queries that we see. I've listed potential reasons that are the causes for all unwanted queries that come to the root server. The most common ones are misconfigurations or default forwarding policy for public DNS resolvers. One interesting thing that we find, which previous research has also pointed out, is Chromium-based queries. So any users with Chromium browsers installed on their devices, when they try to access the internet, Chromium sends out 3 randomly generated queries to root servers to detect the presence of captive portals. Since we are here at the conference, I think every time we do that, I think Chromium-based browsers send out these queries to the global DNS. This is a broad categorization that we propose. The top part, which is about 27%, is the only set that accounts for productive or useful queries at the root server that we expect to see. The others, 72% and more, are just unwanted queries. The final goal of my research is to try to minimize these queries, if not get rid of them completely. This data is for 2023, and the total queries that we saw during that 48-hour period window in 2023 was over 11 billion queries. What do we want to achieve by this research? Firstly, we want to identify unwanted queries. We have been working on that, and we are trying to find the source of each of such unwanted queries by proposing different categories. By using these categories, what we think we are able to do is we can identify possible misconfigured DNS resolvers as such, and also suggest changes to querying mechanisms at different entities in the hierarchy. For repetitive queries, we are currently working on finding an optimum TTL value, which we think is definitely going to be lesser than what is recommended by the TLD operators as of today. For competition challenges and previous work, as I mentioned before, the first work in this direction was conducted in 1992. What they found during those past works was a lot higher number of unwanted queries. As we can see, the research in 2008 found that more than 98% of queries incoming were unwanted. That has reduced now, but 70% we believe is still a lot. So unwanted DNS traffic exists even today, and we believe there is a need to get rid of this. Next slide, please. In conclusion, my research currently aims at analyzing incoming queries to DNS b-root server and provide a comprehensive plan on how to deal with these queries. The plan is to identify root cause of each of the unwanted queries and propose a categorization so that we can handle unwanted queries at the source instead of having them come at the root servers. With this, we aim to improve the efficiency of root servers in terms of saving computational and operational resources. Overall, we believe this research will help us in enhancing the sanity of the DNS ecosystem. With that, I'll be happy to take questions. Thank you.
Thank you, Dipsy. Very interesting presentation. Any questions for him? Naveed, please.
Yeah, this is Naveed. Thank you for the presentation, Dipsy. So it's very interesting work. Just a few clarifications. One is when you present that this data is from b-root server, is it the data for all the instances collectively or for one instance? That's my first part of the question. And the second is, how do you see this would differ if you engage more root server data together? For example, not all root servers have the same distribution of instances. Some have much more than others, right? So having them collectively or doing a study or other root servers, how the categorization would be different. And do you plan to have some kind of mathematical modeling on that so that we can predict for sure or categorize them for sure, no matter what kind of root server or what kind of instance we talk about? Thank you.
Yeah, sure. So the data that we observe is for all instances of root servers, all instances of b-root server. For the second question, I think if we consider data from multiple root servers, we probably would come up with much finer categorization. That is, let's say if we have 12 categories now, we might come up with subcategories for each of them, or maybe multiple of them. I don't think that would directly tie back to the number of instances other root servers would have. It is just that it would give us access to a larger chunk of data, and we might find some anomalies there which we do not see at b-root server. And using data from multiple root servers, I think mathematical modeling could be possible, but we have not looked into it as of now.
Just a clarification, when I say that some root servers have more instances than others, the probability of receiving more, unwanted queries for them would be more, right? So there I see more maybe some categorization that you might not find here, for example, right? Because they are displaced all over the world, they have more instances. So the probability of having such behavior would be more. That's what I was thinking.
Yeah, definitely. I think that would result in a larger chunk of data, and we would definitely be able to see more anomalies.
Thank you. Any other questions? We have time for one more question. Paulo, please.
Paulo Dreviake here, NextGen mentor. Great presentation. Why the b-root? And why? How do you imagine like expanding this work? Do you imagine on expanding this work, and how are you going to do it? Since it's the word of the day here, so are you going to use any kind of AI to analyze this?
Yes, thank you. b-root, because I study at University of Southern California, Information Sciences Institute is the operator for b-root. So we had easier and less troublesome access to the data. The goal of this research is definitely to try to come up with mechanisms that can be adopted by multiple root servers, if not all of them, so that we can potentially reduce all the unwanted queries and save on computational and operational resources at root servers. Because DNS is a free complementary service that is available today, and then we can save on resources that are not being utilized to the best, then I think that would probably be the best use of our research.